Good evening, everyone. Welcome back after the summer break. Great to be back here. It is, in fact, our September Speakers Night for 2024. Welcome to the Rask Toronto Centre. We are online tonight, and I am Dr. Elena Hyde, the second Vice President of Rask Toronto Centre. This is our Speakers Night presentation. So please note that this meeting is an online only presentation and not at the Ontario Science Centre or our new York University meetup location. It's online only. So later on tonight, our president, Tom Luton, will be talking about various programs. But first, we have a special event to kick off. And to get us started, I'd also like to start off with a land acknowledgement. So to just acknowledge that the Royal Astronomical Society of Canada, Toronto Centre, meets on the traditional territories, excuse me, of many Indigenous nations, including the Haudenosaunee Confederacy, the Huron-Wendat, and the Mississaugas of the Credits First Nation, as well as other Anishinaabe peoples. These lands are part of the Dish with One Spoon Treaty and are now home to many diverse First Nations, Inuit, Métis, and other Indigenous peoples from across Turtle Island. As we engage in astronomy here tonight, together, we respect, learn from, and honor the deep relationship between Indigenous peoples, the sky, and the earth. Now, to get us started for our main event today, we will in fact have a wonderful guest speaker, but I'm actually going to mix it up just a little bit and start off by mentioning C2023, the comet, also sometimes called A3 for short, which is coming back past Earth soon. So you might have heard or seen things on the news. Wonderful pictures are coming out of Australia, just to give you a teaser of where our speaker might be from. In Toronto, we're going to have to wait until October, really October 20th, to get really good pictures. And this comet and many others are exactly the kind of thing you would TM not want to hit you here on Earth. Now, tonight we have here to talk with us about a much older and very impactful Earth encounter, Dr. Chris Matthew from Australia, so coincidentally. So it all works together very, very well with this upcoming event. Now, Chris has had a lifelong passion for space history, aerospace technology, all kinds of aspects of astronomy and astrophysics. He has a PhD in ancient history from Macquarie University, a master's science degree with a specialization in astronomy, and a PhD from Western Sydney University. And he's has a graduate certificate of space operations from the Australian Defence Force Academy, and he's actually currently doing his third PhD in aerospace engineering. He's worked part-time at the Penrith Observatory in Sydney, which is a lovely place, where he's assisted in public outreach, and he's also been a former lecturer of ancient history at the Australian Catholic University. He's had many, many lectures over all kinds of things, and I'm sure I'm not the only one who's looking forward to hearing more interesting archaeoastronomy and potentially comet related at no at that. This one is coming from Jordan, but I won't spoil the talk too much. It's very interesting, potentially an airburst, and if it was a comet, as they say, it must have been a real rock star. So we're going to go ahead and go ahead and hand it over to Chris now. So please take it and us up, up and away and back in time. Over to you, Chris.
Thank you, and hello to everyone, no matter where you are and whatever time of day it is when you're watching this. Yes, I'm Dr. Chris Matthew. I'm talking to you from sunny Sydney, Australia. It's currently 9:30 in the morning here. Before I get into the presentation proper, just a couple of things to clarify. Yes, I am an Australian. Yes, I talk with a funny accent. So if I say anything during the course of the presentation that you don't quite catch, please feel free to drop a question or a comment into the chat, and I will try and revisit it when we get to the Q&A session at the end. I promise I will not be offended in any way, shape, or form. Now, what I'm going to be talking about tonight is giving you an overview of the findings from an archaeological excavation at a place called el-Hammam, which is in Jordan. Some of you may be thinking, hold on, isn't this a presentation for an astronomical society? Why is he talking about archaeology? One of the things that hopefully you will discover by the end of this presentation is just how several disciplines that you might otherwise think have no relevance to each other. So, for example, astronomy and astrophysics on the one side and archaeology and ancient history on the other can come together to solve some rather puzzling questions. Much of what I will be discussing has been published in a number of papers. A lot of it in this particular presentation will be based on an article that came out in Nature Science Reports a few years back by Bunch and all of their collaborators. And they're the ones who were undertaking these excavations in Jordan. So just to provide a bit of geographical context for where this is all taking place, here's a satellite photo of the region. The dark line you can see snaking down in the middle from the top is the Jordan River. So on the left is Israel, on the right is Jordan, with the Dead Sea sort of center-ish at the bottom. You can see the site of Tel el-Hammam over on the right, and another site called Tal Nimrun, which I'll be mentioning a few times throughout the presentation, just to the north of it. On the other side of the Jordan River, you can see the site of the city of Jericho, and also I've just marked the city of Jerusalem just to provide a bit more geographical context. Excavations at this site have been ongoing since 2006. They were led by a team from Veritas International University in California and Trinity Southwest University in New Mexico. It started out as a fairly standard, I guess you would say, archaeological excavation, but then soon expanded to incorporate geologists, engineers, astronomers, astrophysicists, chemists, remote sensing specialists from all parts of the world. Unfortunately, I was not part of any of these teams because this was quite a fascinating excavation. So this is a photo of the main part of the site. It is one of the largest occupational mounds in the Jordan Valley, and the excavations have shown that it was continuously occupied for several thousand years. The earliest dated artifacts go back to about 4,700 BC, and then occupation ceases around 1650 BC. So it was settled initially somewhere around 6,600 years ago. The main city was surrounded by fortification walls, which were 4 meters thick. It had monumental gates and towers. The urban area covered an area of 30 hectares, which is 5 times larger than the city of Jericho over in Israel. It had large temples, a multi-story palace complex, and it was really a very large settlement that completely dominated the Jordan Valley. It then has signs of sudden destruction and complete abandonment around 1650 BC, and it is not occupied again for another 600 years. Within the signs of the destruction that have been dated to 1650 BC at Tel el-Hammam, there are a number of signs of something catastrophic happening. So there's a debris layer, first of all. This contains ash, it contains charred roof beams, deposits of rubble and shattered buildings, and this in places is up to 1.5 meters thick. All walls at the site, so every building is sheared off about 1 to 2 meters above ground level. We do see this at other sites, such as at Pompeii in southern Italy, for example, where the pyroclastic flow from Mount Vesuvius has literally sheared off the first floors of every building in the place. Mud bricks at Tel el-Hammam were mostly pulverized by whatever happened, and the debris was scattered to the northeast. Pottery was melted, which indicates there was some sort of extreme heat. Mud brick was also melted. Roofing clay, plaster, all show signs of intense heat and melting. Small clumps of iron formed spherical nodules called spherules, and when these were analyzed, it turned out that the particles within these spherules had been magnetically polarized. This means that they've been subjected to intense heat and pressure coming from one particular direction. There were a few skeletons that were found at the site in this layer, and all of them seem to have, for lack of a better term, shattered. These people had every bone in their body fractured in numerous places. In other locations, things like plants had been blown into the melted mud brick or the melted plaster and had left imprints. Limestone tiles had melted into something akin to chalk. Large stones that were used in the fortification walls and the palace complexes and the temples showed signs of heat fracturing, and quartz granules within sand also showed signs of being fractured under intense pressure. There was also the presence of elements such as platinum, iridium, and palladium, up to 8 times greater than average than is found anywhere else on the Earth's surface. This all led to a number of questions being raised about what had actually happened at the site. So here's a couple more photos of the site. 4 main excavations took place when this paper in 2021 was published. One in the palace complex on the main occupational mound. There was another one on a ring road, another dig site at a temple, and one further afield from the main city itself down in a dry wadi or dry creek bed. All of these contained these debris layers and these ash layers. You can see these in the small images at the bottom of the screen. And again, this showed that whatever had happened at the site had occurred across the whole area. This is some more photos. This is of the excavation of the main palace. Again, you can sort of see the debris layer and the ash layer within the floor of the palace. You have the remains of charred roof beams. This is photo D in the bottom right, and the remains of some other wood in photo C, bottom left, as well as broken pottery and other jars and containers as well. So there is widespread destruction right across this particular site. One of the other things that they found was the presence of nanodiamonds or diamondoids. This is something that happens when carbon atoms are exposed to very high temperatures and very high pressures. And so these small carbon atoms become almost microscopic diamonds. Um, in some places where the heat and the pressure wasn't sufficient enough to create the diamondoids, the carbon atoms were fused together, but they weren't quite exposed to enough conditions to create these micro diamonds. So the investigators then brought in a whole bunch of chemical specialists and people who could undertake chemical investigations of all the different elements that were found at the site. You can see on the right a table of all the different things that they examined, and on the left, just a list of some of the different processes that they undertook to examine all of these different elements and compounds. What's really interesting about the results of this chemical analysis is that of all the different things that they tested, all of them seem to have been subjected to extreme heat and have melted in some way. But 74% of all of these things have to be subjected to temperatures in excess of 1300 degrees centigrade for them to melt. 45% require temperatures in excess of 1600 degrees, and 18% require at least 2000 degrees in order to melt. So again, signs of something catastrophic happening, something with very high pressure and very high temperature. The carbon dating at the site sort of confirmed a destruction date somewhere around 1650 BC, with the results of the carbon dating coming back with a reading of 1661 BC plus or minus 21 years. So then the investigators needed to try and work out what had actually caused this widespread destruction. And to do this, they came up with 17 criteria for comparison. So whatever had created the destruction at Tel el-Hammam had to, for example, be something that was hot enough and created enough pressure to create the iron spherules. There are also titanium rich spherules. There's some silicon rich ones. It has to create enough heat to melt pottery, mud brick. It has to have some sort of force behind it to create the plant imprints. It has to account for things like the platinum and iridium peaks. It has to be able to have enough heat to ignite anything combustible at the site and create the ash layer that is found in the destruction layer, as well as burning any other biomass that was there. It has to have enough heat and pressure to create the diamondoids, and it also has to be able to create the shocked quartz. It has to shatter human skeletons. It has to create some sort of wind or pressure wave to move most of the debris in a northeasterly direction, and it has to account for the polarized magnetism in the iron spherules as well. So then they start to employ all sorts of other specialists, historians, physicists, and so on, and try and come up with what had actually happened. And they sort of threw out ideas, regardless of how silly they may have seemed at the start, just to try and come up with every possible reason for what had happened. And so they thought maybe it is the result of human activities. Are they excavating sites where there was human activity such as glass or pottery making or metal smelting that created a lot of heat? Could it have been a citywide fire or a fire in one of the rubbish areas of the city, or just a wildfire in the region? Was it the result of an earthquake or some sort of volcanic activity? Could it have been lightning strikes that had caused it? Was it the result of warfare? And finally, could it have been some sort of impact by a meteorite or a comet? Some of these options can be easily dismissed. So, for example, the chance of excavating a site that covers tens of hectares and just happening to excavate 4 spots that are related to human activity is remote in itself. Secondly, even a site that's related to glass or pottery making or metal smelting will not have produced enough heat or pressure to account for all of the 17 criteria that they were using as a basis for comparison. Similarly, a city fire or a wildfire or a midden fire could not have generated enough heat or pressure to account for what they saw at the site. There are also no signs of earthquake or volcanism in the region at the time, so that one could be ruled out. And it's also unlikely that you were just lucky enough or unlucky enough to excavate 4 spots where lightning had struck. Lightning also could not have produced enough heat or pressure to account for what they witnessed at the site. War was also ruled out. What happens when you look at an excavation at a site that has been destroyed in a conflict, especially one in ancient times, is yes, you will find this debris layer, usually an ash layer as well, but you also find the remains of weapons, usually lots of arrowheads or sling bullets, occasionally swords, things like that. So you have this layer at Tel el-Hammam with the ash and the debris, but there's no weapons found at the site. Over in nearby Jericho, there is also an ash layer dated to around 1650 BC, but again, there are no weapons or weapon fragments present in the layer. Similarly, at Tel Nimrun, just to the north of Tel el-Hammam, there's a similar ash and debris layer, but again, no weapons. Some of these sites, after they were reoccupied, did see destruction at the hands of conflict, and in the debris layers for those time periods, you do find weapons, but you don't find some of the other things that are found at Tel el-Hammam, such as the melted pottery, for example. And so what this led everyone to conclude is that there's some sort of large, intense burning in the region around 1650 BC, and all 3 of the sites, Jericho, Tel el-Hammam, and Tel Nimrun, are destroyed simultaneously and relatively quickly. So that means, or left, only the option of a meteor or comet impact or possible airburst. And when they started to investigate this further, they found that such a cause actually met all 17 of their comparative criteria. Now, as a comparison, they also thought, okay, we'll get a bit wild with our speculations. What happened if someone dropped a nuke on the site? And so they were analyzing the Trinity test site in New Mexico, and they found that based upon the records and the evidence from that, even a World War II era atomic bomb would only meet 15 of the 17 criteria. So something like that, other than the technological anachronism, was ruled out. So they've settled finally that the site was probably destroyed by some sort of airburst, whether a comet or meteor. This was because there's no visible crater at the site. And based upon the computer modeling and the computer simulations, it's probably an airburst of a stony meteorite a little bit less than 80 meters across. And so using the computer simulations, they did a simulation of an airburst by a 60-meter stony meteorite and also a 75-meter stony meteorite. They had it coming in at a 45-degree angle of impact, and they had it explode 5 kilometers southwest of Tel el-Hammam. In the simulations for the 60-meter meteorite, it came down through much of the atmosphere and exploded at an altitude of 4.7 kilometers with a blast equivalent to 12 megatons. This created, or would have created, a shockwave at the site of Tel el-Hammam that traveled at speeds of 915 kilometers an hour. So this is 2 times greater than the biggest F5 tornado ever recorded. The simulation for the 75-meter meteorite came down through more of the Earth's atmosphere. It exploded at an altitude of 1.3 kilometers with a blast equivalent to 23 megatons. So in comparison, the atomic bomb that was dropped on Hiroshima in 1945 was 15 kilotons. So even the smallest meteorite is, orders of magnitude more powerful than that explosion. The 75-meter meteorite, when it burst at the altitude of 1.3 kilometers, would have created a shock wave at the site traveling in excess of 1,200 kilometers an hour, and both of them would have created seismic shocks in the Earth's surface equivalent to an earthquake of magnitude 5 on the Richter scale. Both of them would have created a fireball about 1 kilometer across, with temperatures at its core in excess of 300,000 degrees centigrade, and a thermal pulse spreading out from this blast that would have been in excess of 1,700 degrees at Tel el-Hammam for more than 25 seconds. This would be more than enough to melt silicates and create most of the damage that was seen there. And just as a comparison again, if you take a human and you suddenly expose them to a temperature in excess of 150 degrees Celsius, that is going to be instantly fatal. But 1,700 degrees is going to more or less vaporize most people. So this is an overview again of the site. The red and the orange shaded area is the area of the Tunguska airburst that happened in Siberia in 1908. And you can see that the scale of the destruction in 1908 would have easily encompassed both Jericho and Tel el-Hammam, and also Tel Nimrun just to the north. On the right, you can see a comparison between Tel el-Hammam, Tunguska, and the Trinity atomic bomb test in 1945. The yield for Tel el-Hammam is greater than possibly Tunguska, although the two are comparable. Trinity has a similar fireball temp, and also the ground temperature is very similar in both cases. Although for Trinity, the initial thermal pulse only lasts a very short time. It's only about 3 seconds, where for Tel el-Hammam, we're talking about nearly half a minute. The blast area is very similar for Tel el-Hammam and also Tunguska, and the wind speed for Tel el-Hammam is far greater than either of the two. I couldn't actually find details of the wind speed that came out from the Trinity test, but that's just something I'll have to look into a bit further. So these things have happened before in the past, and they are happening all the time. What I'm going to play for you now is a short video clip from CNN from back in 2013 of a meteorite coming in and airbursting over the city of Chelyabinsk in Russia, just to give you an idea of what may have occurred on that day back in 1650 BC.
Anderson Cooper 360, weeknights at 8 and 10 on CNN.
The images look like something out of a movie, a tiny asteroid tearing through space at a speed of 33,000 miles per hour before streaking across southern Russia. Cameras caught sight of the white trail as it headed across the sky. And then this. An explosion of light, then a massive sonic boom. Strong enough to shatter windows and damage buildings. There were reports of more than 1,000 people injured, mostly from glass and debris. This video shows a children's judo class. Windows blew out here and in buildings around the region. Some people said they thought it might have been a plane crash. This is the aftermath of the blast in a high school. A 17-year-old student put this video on YouTube, showing the reaction in his physics class. Students screamed and ran into the hallways. He said some in the class thought war had started. Some of the incredible images were caught on cameras placed inside Russian cars. Many drivers now record their journeys in case of crashes or run-ins with police. Shock and gasps at the blinding light, the boom, and all the shattered glass.
Asteroid. Реально.
Jim Bolden, CNN, London.
It's just some amazing footage.
Anderson Cooper.
So we can compare what happened at Chelyabinsk also to el-Hammam. So the impactor, or the meteorite that was coming in at Chelyabinsk, was only 20 meters across, but it still weighed about 12,000 tons. We're looking at something 3 times the size or more that impacted at el-Hammam. Chelyabinsk seems to have had a slightly higher altitude when it airbursts as well. The reports I've been looking at are suggesting as high as 30 kilometers, where at el-Hammam it was much, much lower, down to possibly only 1 kilometer. In terms of the yield, Chelyabinsk exploded with a power of 500 kilotons, compared to somewhere between 12 and 23 megatons for el-Hammam. And the fireball temp is estimated to have only been around 4,000 degrees at Chelyabinsk. Have no readings at all for the ground temp at Chelyabinsk. That's because most of the airburst occurred over pasture land where there wasn't anything around to record. It was also quite snowy, and large parts of the meteorite that did survive the explosion fell into things like a lake, so they were quite hard to get a hold of. But the blast area is similar, both around 2,000 square kilometers. At Chelyabinsk, the shockwave traveled at around 750 kilometers an hour. It did cause seismic shocks in the Earth's crust. They were recorded as being equivalent to an earthquake of 4.2 on the Richter scale, and they actually traveled around the planet twice. So just after the initial airburst, all of the seismic monitors in, say, Eastern Europe started picking up the shockwave as it traveled through, and then sometime later they picked them up again as the shockwave literally went around the planet and then came back and kept going. Something similar would have happened at el-Hammam, just because of its greater magnitude of force and the larger scale of the seismic shocks. So do we have any historical references to this? We do, like for Chelyabinsk, in this day and age, have lots of technology recording incoming meteorites. Interestingly, for Tel el-Hammam, the site is thought to be the location of the biblical city of Sodom. And Bunch, in his paper, actually states that the oral traditions about the destruction of this city by a cosmic object might be the source of the written version for the destruction of Sodom in Genesis. And so when you look at the biblical passage in Genesis book 19, chapter 19, verses 24 to 25, it says, "Then the Lord rained upon Sodom and upon Gomorrah brimstone and fire from the Lord out of heaven, and he threw down those cities and all of the inhabitants of the cities and that which grew upon the ground." Now, the thing is, the Old Testament, particularly the book of Genesis, was written around 800 BC. So this is 850 years after the destruction of Tel el-Hammam. And what seems to have most likely occurred is that the writer of the book of Genesis has incorporated a much older oral tradition about the destruction of Tel el-Hammam by this meteorite airburst. And that has then been worked into a much later biblical passage to account for the city's destruction, and from a Hebrew perspective, to extol the power of their God. You also have references to the destruction of Jericho. The excavations that I mentioned showed that Jericho was destroyed at the same time, around 1650 BC. And much like Tel el-Hammam, it is not reoccupied for around 6 centuries, with reoccupation occurring sometime in the 10th to 9th century BC. However, the biblical account of the destruction of Jericho says that it is destroyed by the army of Joshua sometime around 1200 BC. But the interesting thing is the site itself is not actually occupied at this time. There is no city there to be destroyed by Joshua. But the biblical book of Joshua, 6:20 to 21, says, "At the sound of the trumpet, the wall collapsed, was destroyed, every living thing in it, burned the whole city." And this sounding of the trumpet in the book of Joshua is again most likely an oral tradition about the sonic boom of the airburst. And the tale of the destruction of Jericho has been, again, sort of incorporated into a biblical passage written sometime after the 8th century BC, but it's been attributed to a conflict and a battle that never actually took place. So where do we go with this evidence from here? So work into the impact, and as I've said on the slide, pardon the pun, of comets and meteors on the development of human civilization is an emerging topic of scholarly research. And this is sort of going hand in hand with the current work that is being done for monitoring things like near-Earth objects. And you may have seen recently the NASA mission to deflect asteroids. This is the other bookend of that research. So, for example, there's been a couple of very big impact sites identified in Australia. One back in 2018, another one was earlier this year. One of these craters, or at least the lava field that was created by this impact, is so big it actually covers about a third of our entire country. And they think that this impact may have led to the Cambrian extinction around 485 million years ago, which then changed the whole course of the evolution of basically everything on the planet. There have also been other items discovered in the historical record that lead to other areas of meteorite impact and meteorite research. You can see on the left an image of a dagger that was discovered in the tomb of Tutankhamun in the Valley of the Kings in Egypt. This dagger was fashioned by the Hittite culture who occupied what is now Turkey, and seems to have been given to the young Egyptian pharaoh as a gift or an offering. The really interesting thing is that the blade is made of iron, but it's made in a time where everything is either bronze or just copper. And chemical analysis of the blade seems to suggest that what the blade is made from is a melted down iron meteorite. And just recently, there has been another investigation into a meteorite impact in Syria. I mean, this region in the Near East seems to just cop so many meteorite impacts. But this one dated to around 12,800 years ago seems to have caused a huge climatic shift in the region and may have actually been the catalyst for the change in early humans from hunter-gatherers to sedentary farming. And so basically this meteorite impact gave rise to civilization as a whole. So there's lots of different things going on in this field. We will just have to wait and see where things go from here, what new discoveries are made, and then try and work backwards to try and see if we can correlate any of these cosmic events with other fascinating areas from the historical record. That's assuming we don't get hit by a meteorite ourselves before we get to come to any conclusions. Thank you.
All right. Well, thanks very much. It's a controversial to say the least, but a very fun investigation. Chris, it's been great to have you present this, and I have heard, it's this one may or may not be a comet, might be something else, and they do say to overuse a pun, the best material is in the comets. So we're going to see if that same is true for questions, and go to our own comments or comments and see what kind of questions are over in the chat. So we've got a few coming in. Obviously, it is, as you say, it's an archaeological and astronomical investigation. There's always a bit of controversy. So I actually just address one quick. I'm not sure that it's been answered, but there is a question in the chat apparently about the RASC meetup after the meeting. The pub at York University is the Timber Pub. So just in case, I won't make our speaker answer that because he's in Australia. Now we do have a different question more about the talk. This is from Brenda Shaw, it looks like, and it's sort of a comment followed by, I think, a question that Stephen Collins, the director of archaeological excavation, is also the dean of Trinity Southwest University, an unaccredited evangelical Christian school. And there's apparently a book published on the subject of historical Sodom that would argue he is biased in favor of finding that it's destroyed by an airburst. So that, I suppose, is a question about the evidence, and that this, of course, some of these papers have been called out by impact scientists as not having quite enough evidence to support one over the other.
Yeah, I mean, that's one of the challenges when dealing with anything historical is not only the bias of the sources that we may be using and the bits of evidence that we may be using, but also the biases of ourselves when we're trying to write a paper or things like that. One of the things that I would suggest indicates, maybe not indicates, but one of the things that suggests that the conclusion that it's an impact or an airburst is not overly biased is that it is one of the only scenarios that would meet all of the criteria for making or producing the evidence that we find there. Now, you can't definitively say one way or the other. That's just not in the nature of science. You have to be open to all possibilities. But as you start to rule out all of the other options, such as human activities, lightning strikes, volcanism, that sort of thing, the list of what it could be and what has caused this starts to get quite small. Hopefully that answers the question.
Yeah, absolutely. And as you say, there's always room for better investigation of your evidence in any field of science. And if we're looking at stars, we invite other observers to go and observe them. So perhaps there are other archaeologists off to collect more samples and reobserve these.
Yeah, it would be great fun. I would love to run around the desert picking up bits of meteorite.
Well, funding agencies, you heard it here first. And as just as a an interesting aside, as you mentioned, the impact possibilities, we do have some other places where we can more accurately study impact craters other than Earth. So a lot of the, as you mentioned, material that was melted and affected, potentially, we have seen similar things on places that have had impacts that are easily viewable, like our moon, which just recently
Yep.
had that partial eclipse in Toronto. If you've been looking up, you will have noticed a lot of craters. So there is some chance for people to potentially view some things in the solar system to get their own opinions on craters. Let's see here. Um, do we have an? Oh, we do have another question that's come in from YouTube. Um, so looks like they have a question on a specific paper. This is from, it looks like, from Brenda. She's saying there's a paper about no mineralogical or geochemical evidence of impact at el-Hammam that was published in 2022 on the Science Rep 12. So just, I suppose, to show that it is still an investigation in process.
Yes, and I think also when you get an investigation in a site that has some fairly strong ramifications, theologically speaking, that's going to be sort of grounds for controversy just in itself. And I think in a way that is going to cause better research, because regardless of which side of the fence you are going to sit on, and regardless of whether there's any inherent bias or anything like that, you are going to want to be able to produce the best case you can present. You're going to have to make sure that all your evidence lines up, that there's no margin for error, and that sort of thing. And because that's almost impossible with most fields of academic study, that is just going to cause counter arguments and so on and so forth. But that in itself is basically the essence of research. You create stuff or at least I create stuff with the intent of having people engage with it, and whether they engage with it positively or in some sort of critical way and come back and say, well, I don't agree with this. That's exactly what I want, because if someone comes back and says, I don't agree with what you've said here, then it makes me go back and look at my findings again. Maybe I haven't presented something in the right way or said something as strongly as I should or presented evidence. And I think this is what we're going to see here. There is going to be claim and counterclaim going back and forth, and eventually we will get to the bottom of it and find out what actually happened at these sites, and we will all be all the richer for it.
Yeah, absolutely. I totally agree, and I love seeing the, as you say, let's follow the evidence. And when the strongest evidence comes out, it's really great to see, the scientific community who are behind the evidence, sort of change their minds as things change and as we get better, as you say, recordings, better measurements of real data, and that's the key. Data must be king. Now, I think we have time for one more quick question. And then we're probably out of time for questions, but I haven't quite been keeping track. We have one from Ray Viola, who asks, what about the land between the three sites that were destroyed? Has there been any analysis of the larger area?
That is a fantastic question. And as far as I know, no, which seems rather odd. Yes, funding agencies, please take note. I'm open for that as well. But yes, I think if you could get a team in there and start doing just core samples, even just between Tel el-Hammam and, say, Tel Nimrun, just to see the extent of whether this, say, ash layer extends that far, or whether it's just the sites. I mean, in theory, if there's been a big thermal pulse, then everything around, trees and shrubs, should have been burned. If it has this huge shock wave and this blast, then you should get things like the iron spherules all over the place. But as far as I know, no one's investigated that. That is a brilliant idea.
Yeah, absolutely. And oh, okay, we have one more quick one. I think this will be just quick enough to sneak in. I hope we're not going too much over. Mark Downing says the Minoan civilization was destroyed by a volcanic explanation, and it seems to have been a dangerous time, basically.
Yeah. So we've got this is again somewhat of a scholastically controversial topic about how, say, the eruption of Thera, which is the modern island of Santorini, may have or may not have had on the decline of the Minoan culture on Crete. But it is entirely possible that these sorts of events, whether they're cosmic in origin, whether they're volcanic or whatever, they're going to play a major role in the development or the decline of anyone and any civilization that's in the area, and change the course of things in directions that they probably wouldn't have even considered. So they are very much the catalysts that drive a lot of developmental change throughout the course of human history.
Absolutely. All right. So go ahead, and I think thank you once again. And it is interesting, as you say, the chance that there was some kind of touchdown on Earth always captures people's imaginations. And I would just go as far as to posit that it's actually something astronomers and some of our colleagues share with our football friends, is that we strive for touchdowns. But in this case, the touchdown itself is a bit of a mystery. So we've had a bunch of questions, and I'm sure there will be more in the comments. So our RASC team will try to keep up with them if they come in after this recording goes out. But I'm going to have to say, thank you once again, Chris. It's been really great having you here all the way from Australia. So have fun viewing that beautiful comet that you guys can see right now. And we're going to go ahead and pass over to the president of the Toronto Centre RASC, Tom Luton. Thanks for waiting all this time. And we're going to pass over to Tom, who's going to finish off our evening and tell us everything else we need to know. So over to you, Tom.
All right. Well, thank you very much, Elena, and thank you very much to our speaker, and thank you very much to everyone joining us at the start of our new Speakers Night season. So my name's Tom. I'm the president of the Toronto Centre of the Royal Astronomical Society of Canada's Toronto Centre, and let's get on with the announcements. So this is one of two types of meetings that we have here at the Toronto Centre. You've just seen one of our speakers nights, and coming up at the start of October is going to be one of our recreational astronomy nights. For those of you joining us live on YouTube, please say hello in the chat. Do as others have already done and enter some questions for presenters. If you're a new member of the Toronto Centre, please introduce yourself. And if you're coming to us from far, far outside the Toronto area, please let us know where you're coming from. So our next recreational astronomy night is Wednesday, the 2nd of October, 7:30 p.m., both in person and online. Andy Beaton will be talking about the sky this month. Charles Young will be discussing do-it-yourself power for your equipment at a dark sky site. And we have one more presentation slot available. Please drop Paul Markov a line if you'd like to present something. And you can watch the show live on YouTube at youtube.com/rasktoronto/live, or you can join us in person at our new home at York University, room 317 of the Petrie Science and Engineering Building. It's just down the hall from the Alan I. Carswell Observatory. Just follow the signs for the observatory, and there's going to be a sign pointing the way to us when you get there. For full directions, such as transit details and driving and parking information, please contact our website. And then coming up, our next Speakers Night meeting on Wednesday, October 16th, online only. Cassia Bond from York University will be discussing galactic archaeology, exploring the galaxy's history with chemical abundances. Again, live here on YouTube. Coming up in activities, we are restarting the Long Branch Park pilot project for City Star parties for members only. So we're targeting a clear night on September the 28th to 29th or October 5th to 6th. Please check out our website for a go, no-go decision based on the weather. And then our more traditional Bayview Village Park City Star Party is the first clear night of October 7th to 10th, except for Wednesday, 8 p.m. to 11 p.m. Again, check out the website for a go, no-go decision based on the weather. And then Millennium Square Public Stargazing, Friday, October 11th, 6 p.m. to 11 p.m. We're going to be on the North Shore of Lake Ontario at Millennium Square in Pickering. Come on down. Observe the moon and stars through our telescopes. Check out some of the astronomy lit that we have. Ask some questions. And you can even bring your own scope and we'll help you point it at the moon. Remember that it's cooler down by the lake. And please, once again, check the website for go, no-go decisions. Coming up at the David Dunlop Observatory in the next few weeks, Friday, September 20th, from 9 to 11 p.m. is DDO Astronomy Family Night. Registration fees are as seen here, and you can register online by following the links found at raskto.ca. And then the Astronomy Speakers Night, Saturday, September 28th. Ron McNaughton, A Trip Around the Moon and to Its Dark Side. Registration fees as listed here, and you register online with the links at raskto.ca. And then Sunday, September 29th, 12:30 to 1:30 p.m. at the DDO is Sunday sun gazing. Again, registration fees are as shown here, and the links to register at rascto.ca. The CAO is open, and things are back to normal mostly. We still ask for folks to mask in common areas, but the preference of those people actually in attendance will be taken. And see the online CAO bookings page for all the details before making your decisions and your bookings. And with that note, I'd like to invite folks. The CAO's fall work party is the weekend of October 5th. If in exchange for some work, we'll feed you, and the lodging is free for the weekend. If you don't know anything that we're going to be doing, we'll gladly teach you. We're pretty close to full already, so if you're interested, time is of the essence. Please contact Ralph at cao@rascto.ca. We'll give you all the details about registering. And just to expand on that, the RAS Toronto Center runs on clean, renewable, volunteer energy. So if you're a RAS Toronto Center member, if you're interested in helping and you've got any free time, please, we'd love to have you. Please give us a shout out at volunteer@rascto.ca. And another segue, Rask Toronto Center is now working with Benevity to receive charitable donations. So if you're a volunteer and your employer has signed up to make these contributions for charitable work, please let us know at either president@rascto.ca or treasurer@rascto.ca. This is the part where I get to plug the joys of membership. If you've liked what you've seen, if you're interested by all the star parties that we're hosting, and if the idea of our observatory sounds interesting, you can sign up or you can renew your membership online at secure.rasc.ca. Gift memberships are also available because the holiday season is not that far away in the future. So contact the national office at mempub@rasc.ca. And with that, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. And again, I invite you to join us in person at York University. And to follow up with Elena's comment, yes, we will be having a meeting after the meeting at the on-campus pub, the Timber Lodge. Full details will be given at the end of the next meeting, where we're all going to walk over. Please follow us on all the forms of social media we've got listed here. If you like what you've seen live, please like and click the notification bell for further updates. Stay safe and keep looking up. Good night, everyone.